Next most important question is explain the term most economical cross section in a canal. Channels of the most economical cross section. A channel which gives maximum discharge for given cross section area and bed slope is called a most economical cross section. In other words, a channel which involves least amount of excavation for the design amount of discharge is called a most economical cross sections. A channel of most economical cross section is sometimes also defined a channel which has minimum weighted perimeter. So there is a minimum resistance to flow the and thus resulting in a maximum discharge. Condition for most economical trapezoidal section. This is a figure. This is a figure of a canal which have B width and D depth. So total we will get B plus 2 into ND because this is the N depth here provided. Okay. Let B is equal to width of the channel at the bottom. D is the depth of the channel. N is to 1 is equal to side slope is equal to n horizontal 1 vertical. Area is BD plus ND square is equal to D B plus ND, where A we put D here this side, so A by D is equal to B plus ND. B is equal to AD minus ND, where discharge we can find discharge is equal to A into V. Area is here, and C, this is a Chase's coefficient, velocity is Chase's coefficient, C is equal to C into under root RS. So A is into C under root R, value of R is equal to A by P, so value of R is equal to A by P, so A by P into S. Keeping AC as constant in the above equation, the discharge will be maximum when A by P is a maximum. When Q A by P is a maximum, when A by P is the maximum, the discharge will be maximum, and perimeter is a minimum. Or in other words, dP by dd is equal to 0. We know that the perimeter of a trapezoidal section P is equal to B plus 2d under root n square plus 1. Substituting the value of B from equation 1, P is equal to A by D from in this equation 1. P is equal to A by D minus ND plus 2D n square plus 1 is equal to 0. Differentiating the above equations with respect to D and equating to 0. So after the differentiating, dP by dt is equal to minus A by D square minus n plus 2 n square plus 1 is equal to 0. A by D square plus n is equal to 2 under root n square plus 1. We know A is equal to D, B plus ND. So we put the value D is equal to B plus ND divided by D square plus n 2 n square plus 1. After B plus ND by D plus n is equal to 2 n square plus 1. B plus ND plus ND, there are if we put value D up here, so B plus ND by D is equal to n square plus 1. So now we have B plus 2ND by D plus 2 n square plus 1. Side slope is equal to the half of the top width. So B plus 2ND by D is equal to D n square plus 1. Okay. B plus 2ND is equal to 2D n square plus 1. Here is a 2. Hydraulic mean depth R is equal to A by P, where A is equal to D, B plus ND, P is equal to B plus 2D n square plus 1, D is B plus ND divided by B plus 2, B plus 2ND. So after all the process we have got R is equal to D by 2. R is equal to D by 2. This is a second equation. For trapezoidal section, conditions for the most economical section are B plus 2ND is equal to 2D under root n square plus 1, and second is R is equal to D by 2. So this is the for most economical cross section of the channel.